Good morning, guys. It is a great day to be in room 625. It is. For today, we are going to work on graphing lines in slope-intercept form. I know we did some notes over these, so I'm not going to go over the notes again. We did that the day we learned out we were going e-learning. We did some notes real quick. So I am going to just do a few example problems. That way you guys see a few more examples of how to do this. And before I even do the example problem, let's look at what slope-intercept form is. Slope-intercept form is y equals mx plus b, where m is your slope, and that's your rise over your run, and b is your y-intercept, where your line crosses the y-axis. And we're always going to graph this one first. We always start off by graphing our point first, and then we apply the slope once we have that point. So let's look to see if we have the equation y equals 2/3 x plus 4. If I am going to graph that line, my first step is to graph that y-intercept of positive 4. So I go my positive 4, I make a dot right here. Now I'm going to use the blue marker to show the slope. You don't have to do this. If I'm doing this for myself, or if we each in homework in, I don't need to see the slope, but so you guys can see what I'm doing, I'm going to use the blue marker. So I'm going to rise up 2. So I'm going to rise up 1, 2, and I'm going to run 3 to the right because it's a positive 3. I run to the right if it's positive, to the left if it's negative. So I run a 1, 2, 3. That's where I make my next dot at. And that is where I can draw my line between those 2 points. But if you also remember, slope is constant, so I could apply that 2/3 every single time. Up 2 over 3. I could also do the opposite. Down 2 over 3. Down 2 over 3. Down 2 over 3. And you don't need to do that every time. You only need 2 points to graph a line. But I want to show you that slope is constant. So if I go through and do my best to connect all those points, and I follow 2, 3, up 2 over 3, up 2 over 3, up 2 over 3, up 2 over. Oh, I messed that one up. That's why I didn't connect very well. Down 1, 2, 1, 2, 3. This point should be right here. That line, it has a constant slope. So once again, you don't need a blue there. Using that dark black line, but that's how we graph. We graph our y-intercept first. Once we have our y-intercept posted on y equals 4, I then go over and graph my slope of 2/3, and so I'm going to go up 2 over 3, up 2 over 3. So that's how we graph that line. Let's do a few more. Let's say I give the equation y equals negative, say, 7/2 x minus 6. So step 1 is to graph our y-intercept on the y-axis. So I'm going to -6 because it's a -6. And then I'm going to do my rise over my run. I'm always going to rise up, so I'm going to rise up 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to run 2, and because it's a negative sign there, I'm going to run 2 to the left. 1, 2, and there is my dot right there. So I can go ahead and connect those dots. Not the straightest of lines, but you see the point. That would be the line of the graph y equals negative 7/2 x minus 6. Step 1, graph the slope, graph the y-intercept, then apply the slope, the rise over the run. Let's try something to be a little bit flatter. Let's try y equals, say, negative 1/6 x. Let's just do that. Negative 1/6 x. You're like, well, we were told to graph the y-intercept first, and there is no y-intercept. Well, if you don't have a plus or minus at the end of it, we can always add one. I can always say this is the same as plus 0. So if you just have the y equals mx and there's no b, that means that this is going to cross through the origin. So my first point is going to be right here at the origin. And now I apply my slope. I'm going to go up 1, and over 6 to the left because it's negative. 1, 2, 3, 4, 5, 6. That's where my second dot goes. I connect those lines right there like so. So if there is no b term, that means it is just going to be a line that crosses through our origin. I rise up 1, and I run over 6 to the left because my slope is a negative slope. And if you think about slope, dude, that is a nice negative slope. On your homework, all I need to see is, I need to see the line at least. I don't mean to erase that. I need to see that right there is what I need to see. All right, let's try it on. Let's make a whole number. Y equals 8x minus, say, 3. Step 1, graph that y-intercept. So we'll go down to 3, make a dot there. My slope is 8. That is not a fraction in rise over run, but we know to make a whole number into a fraction, all you do is make that slope from 8 into 8 over 1. So I'm going to rise up 8, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to run 1 to the right because it's a positive slope. I'll make a dot there. This next thing you don't have to do at all, but I kind of do to help myself out sometimes. I know if my slope's 8 over 1, and what I mean to help myself out, it helps me graph and make a little bit of a straighter line. I go up 8 over 1, but that's kind of a long distance to connect. I also tell myself, okay, that's the same as going up 4, 1, 2, 3, 4, and over a half. Because I just divide both my numerator and my denominator by 2. You don't have to do that. If you have a ruler, it's a lot easier for me. It's kind of hard to connect these dots without a ruler. So we go up. And that is the graph of the line y equals 8x minus 3. So wait, let's try one without a coefficient on our slope. What if I said y equals x plus 8? Let's do plus 6. We're going to go off the top of our graph. X plus 6. Step 1, graph the y-intercept at positive 6. And after I graph my y-intercept, it is time for me to graph my slope. So for my slope, that is going to be, well, m equals x. That's the same as 1x, which is the same as 1 over 1x. So I'm going to rise up 1 over 1. Up 1 over 1, up 1 over 1, or down 1, left 1. And it's going to go right through like so. So that is the graph to the line y equals x plus 6. So when you have just an x there, that tells you that your slope is going to be 1 over 1, because the coefficient of x is just 1. There's that invisible 1, even though we don't see it. So we go up 1 over 1. Maybe I give you y equal, it's this one. This is the fun one. Y equals x. Just y equals x. And at first that looks kind of weird because it's just there's no numbers there. But we could add some numbers. If we added some numbers, we can say that this is the exact same as y equals 1x. And we said if we don't have a b, we can always add a b via plus 0. So this is the exact same as y equals 1 over 1x plus 0. So if there's no b, we know it crosses through our x and y intercept, our origin. And then our slope is 1, so we're just going to go up 1 over 1. Or down 1 over 1. So connect right through all those points. So there is a slope to y equals x. It kind of cuts it straight in half diagonally to y equals x. If it's y equals negative x, it'd be going straight this way. All right, let's do the oddball one. What if I give you y equals 3? Just y equals 3. Well, at first you're like, well, there's no slope. Ooh, there's no slope, so you know there's maybe say 0 slope. If we want to rewrite this in slope-intercept form, we could. This would be the same as, well, it starts with a y. This is the same as y equals, there is no x, so there is 0x plus 3. So it's going to cross the y-intercept, the y-axis at 3. And then we're going to go 0 as a fraction is the same as 0 over 1. So we go up 0, over 1. Up 0, over 1. So it's going to be a horizontal line going this direction. So whenever you have y equals a number and there's no slope, that's going to give you a horizontal line. Right? Let's do another one. Leave that one on there. What if I give you x equals, say, 6? Well, that's not even close to slope-intercept form, is it? There's no y there at all. If we think that we want a line where our x-coordinate is always 6, and a lot of times kids want to do it just like this, and they put it right here. Well, think about the point. This point right here on the line would be 1, 6. My x-coordinate would be 1. No, I need my x-coordinate always to be 6. So where is my x-coordinate? Right here. Where is it always going to be 6 at? Right here. So a x equals is a horizontal line. That marker's about done for. Cut off right there. So is a, or if I said horizontal, I meant vertical. Sorry, is a vertical line. So y equals is a horizontal and x equals is a vertical. When you graph your lines, it doesn't really matter how long the line is. Make it long enough so it's visible. When we graph stuff, I'm okay. So if say the points are right there and right there, just go farther enough where I can see those arrows like that. I do not want to see if the point is here and the point's here. Like your dots should not be your arrows. It should extend past the 2 points. Your line, I want to see your line extend past your points. I don't want your arrowheads to be your points. So this is good. No bueno there. I don't want your arrowheads to be your points. Hopefully you can see that okay. It's kind of tough. I'm trying to think. I think that explains everything we know for slope-intercept form. Please watch this video and watch the other videos as well. And actually, let's do one more example. Let's make it a little more complicated. What if I gave you, stuff everywhere, the equation 6x plus 2y equals 8. What if I gave you 6x plus 2y equals 8? That's not even close to slope-intercept form, is it? No. But we did that. If you think back to the library, we did that whole that one station. We did stations that one day over little equations. The rewriting circumference for r, rewriting volume for the height, or the area for the base. Where we can change the equation around. So here I want to rewrite this equation so it says y equals. So this right here is my variable term right now. I need to get my 2y by itself, and then once I have my 2y by itself, I need to get my y by itself. So to get the 2y by itself, I need to subtract both sides by a 6x. Minus 6x, minus 6x, those cancel out. That leaves me with 2y equals a negative 6x plus 8. And I'm always going to write my x first on my right-hand side. That way it matches up with my slope-intercept form. So then I have my variable term by itself. Now I need the actual variable by itself. So I'm going to divide both sides by 2. And that leaves with y equals a negative 3x plus 4 to graph. So I go to my graph. I make my y-intercept at positive 4. I make a dot there. I'm going to rise up 3, 1, 2, 3, and run to the left 1 because it's negative. I'm going to go up, let's see, 1.5 and over a half to add an extra dot, and connect my dots right there. And there is the line to 6x plus 2y equals 8, which is actually the same exact thing as having y equals negative 3x plus 4. So if I give you an equation that's not already in slope-intercept form, you just need to solve that equation for y and then graph it in slope-intercept form. Hopefully this helps. Watch this video. If you're here, you probably did watch this video. And watch the other videos I've attached to this. They're good. They explain things very well. If you have any questions, please do not hesitate to ask. Good luck. Do your work. And I'll talk to you guys later. Hopefully see you soon. See you guys.